Hello everyone, my name is Valerio Verso. I'm an associate professor for the Politecnico di Torino in Turin, Italy. Along with Alessandra Reggiani, who is a professional lighting designer located in Rome, we are going to be your guides to guide you through this exciting topic, which is materials for the luminous environment, and which is going to basically focus on the interaction between light and material. Remember that you can really understand there is light when the light hits a surface, it's material. So you have a visual effect. We are going to focus much more in more detail on this effect, both in quantitative and qualitative terms about this interaction between light and the materials. So let's get started. So a short introduction to the content, the expected learning outcomes for this model. The goals are concerned with the introduction of the physical concepts to better understand and to describe the interaction between light and materials in terms of reflection, transmission, and scattering. So we learn a new word, probably to many of you, this word will sound new. Scattering is a distribution of light. The model is also aimed at describing in quantitative and qualitative terms to better understand the interaction between light and materials, reflection, transmission, and scattering. And also the model is aimed at offering practical examples, both from the simulation world and from the real world, to better understand and to visualize the different types of reflection, transmission, and scattering, different amount and different properties of this interaction between light and materials. Particularly, a number of dedicated case histories will be presented by Alessandra Reggiani. What you should expect to learn at the end of this model, a more in-depth knowledge and understanding about the physical phenomenon and the perception effect, the perceptive effects of the interaction between light and materials in terms of reflection, transmission, and scattering to some extent. A more in-depth knowledge of the physical parameters, the quantitative parameters, which allow quantifying the reflection, transmission, and scattering. Particularly, we'll see that we need dedicated parameters to understand the amount of light that gets reflected, absorbed, transmitted, scattered, and so forth, based on and accounting for the spectral distribution, the spectral characteristics of the light, of the material itself, and also the direction will play a role. So we'll need to introduce both the spectral and angular parameters to describe this interaction in a more accurate way. Last but not least, an expected learning outcome is a reflection and a critical discussion on the impact of incorporating this transmission, reflection effects into the design process. Through some simulation results and through the case histories presented by Alessandra Reggiani, we'll understand the impact of maybe changing reflectance and transmittance. Small differences, small change in the reflectance of walls, for instance, so the reflection properties of walls, or in the transmission type, so the type of glazing, may result in significant relevant differences in the light distribution across a space, in the luminous distribution across a space. So let's get started. Particularly in more detail, the module will consist of 4 sub-modules. The first sub-module will be held by Alessandra Reggiani, and she's going to focus on the topic light as an architectural material through a number of examples, pictures to describe the interaction between light and materials. The second module, which will be held by myself, Valerio Verso, and we are going to focus on this interaction between light and materials from a quantitative viewpoint and a technical viewpoint by introducing the basic parameters and spectral and angular behavior of materials. So we'll understand how to quantify and to control the different properties, spectral and angular properties of transmittance, reflectance, and scattering. At the end of this module, you're going through an activity This is going to be a self-assessment test consisting of a number of questions on the topics which have been dealt with in the previous sections, of course, just for you to understand if you have already gained a good knowledge and control over these parameters and phenomena and visual effects, or if you maybe need to re-attend a few slides to better focus on the topics, which may be not always super easy to grab at first. Later on, the third submodule again will be held by myself, Valerio Verso, and that's going to be focused on simulation results, practical applications from simulation results. In that module, we'll understand for a sample room. It's going to be an educational building, so a classroom or a laboratory within an educational building, and we'll analyze the light distribution across the space as a function of different properties of reflection or different properties of transmission of the envelope, wall, surface, ceiling, and glazing. Last but not least, of course, the last submodule 4, again held by Alessandra Reggiani, that's going to be focused on case studies. So that's the case history section. You'll see real applications, particularly three real applications explained by Alessandra Reggiani. So the first submodule will be held by Alessandra Reggiani. So now we are going to listen to her first presentation. And for the second submodule, that's going to be me again. So guys, see you at the end of first submodule for submodules 2 and 3. Take care, have fun with light and materials.